Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 14 from the practice test 2 for the paper 2 IGCSE Cambridge 2025. This is one of the papers that was released to give us some practice of the type of questions that you'll get in the new non-calculator type of paper. So there was a series, there was like a test that was given, practice paper, then there was practice test 1, practice test 2, and so on. There was a few of them. This is practice test 2, question number 14. Now it says we're given this circle with some lines and shapes in it, and this line, it says A, B, C, and D are all points on the circumference of the circle. That's very important. They're all on the circumference of the circle, and that will be something that we're going to use on the circumference of the circle. EF is a tangent to the circle. So this is important as well. It's a tangent to the circle at the point C. Angle BAD is 68 degrees and angle BC is 50 degrees. Those are marked. Find angle CBD. So first of all, we need to be able to identify where the angle is that we want to find. So it's asking us to find angle CBD. So CBD is the angle over here. The angle is always, if you want to identify angle CBD, it's the letter in the middle is where the angle is, and the two letters on either side are where the angle originates from, where the arms of the angle are. So C, B, D, this is the angle we're trying to find. Okay, that's the angle we want to find. Now, they give us, it says, give a geometrical property to explain each step of your working. So sometimes they don't ask this. In this case, they're asking that. So that's something we should be ready for. So now I'm going to explain my steps over here and then copy and paste them down because I want to see this in front of what I'm doing. So basically, I can think of a couple of things that we could do. One of the things that we can do is we could use the fact that A, B, C, and D are all points on the circumference of a circle. Okay, so if I join A to B and B to C and C to D and A to D, I get what's called a cyclic quadrilateral. A cyclic quadrilateral. Okay, so we can say that angle BAD, which they told us, okay, is, I'll do it properly. I'll do this. I'll say angle BCD, sorry. Okay, this angle here, angle BCD is equal to 180 minus angle BAD. Why? Because the opposite angles in a cyclic quadrilateral are supplementary. So opposite angles. Okay, now I'll just take this down now. Okay, so I'll put it down here. Okay, opposite angles in a cyclic quadrilateral are supplementary. Opposite angles in a cyclic quadrilateral are supplementary. Supplementary. Okay, so because we know that the opposite angles in a cyclic quadrilateral, they add up to 180. Okay, so this is going to be 180 minus 68. So 180 minus 68, if I want to find out, that's going to be 112, isn't it? Because 180 minus 70 would be 110 plus another 2. We can also do it like this. Take one from there, put it there. That's 10 minus 8, which is 2. 7 minus 6, which is 1, 1. So 112. So this is 112 degrees. Okay, so we can say that this is equal to 112 degrees. So that's a geometrical property to explain the first step. Now we want to think about, we've got this angle here. How's that going to help us? Well, there's two things we could do now. One of the ways we could do this is to find the angle over here, angle FCD. And we know that angle FCD and angle BCD and angle ECB, they all add up to 180 degrees because they're on a straight line. This is a tangent, which is a straight line. So we can work out what this angle is by 180 minus the other two. So we can say FCD, angle FCD, is equal to 180 minus 112 plus 50. Was that 50 there? Plus 50. Okay. And we can say, what's the reason? You can say angles on a straight line. Angles on a straight line. Okay, try and be a bit neater than I am. Okay, so this is going to be 180 minus, that's 162, which is going to be, that's going to be 62 plus 8 is 70, so it's 18. And again, if we're not sure, we can do 180 minus 162, take one from there, 10 minus 2 is 8, 7 minus 6 is 118. So that's 18 degrees. That's angle FCD, which is this angle over here. And now we're going to use a property called the alternate segment theorem. When you have a tangent that intersects a chord. So we have a tangent intersecting a chord. Okay, so you've got this tangent intersecting this chord. Right? The angle between the tangent and the chord is equal to the angle that is subtended by that chord onto the opposite side of the circle. So the angle subtended by that chord onto the other side of the circle. So this angle here and this will be the same. This angle and this angle is the same. So this is going to be 18 degrees, which is what we want to find. So angle CBD is equal to angle FCD because of the alternate segment theorem. So we can say angle BCD is equal to angle FCD. FCD, so BCD, no, sorry, angle CBD, sorry, CBD, what am I doing? My bad, CBD. Angle CBD, which we have to find, CBD is equal to angle FCD. So angle CBD is equal to angle FCD. Okay, because of what? The alternate segment theorem. Okay, so that's equal to 18 degrees. And there's our answer. Okay, so angle CBD is 18 degrees. Okay, there's also another way we could have done this, which is kind of similar. Okay, is I could say that this angle here is equal to this angle over here because of the fact that they are also alternate segment, because of the alternate segment theorem also. Okay, so this angle, let me just put it in a different color instead, that'll be better, more suitable. Okay, so this angle here and this angle here are the same also. So alternatively, we could have written, I'll just put it in a different color. Alternatively, we could have written that angle BCE is equal to angle BDC. Okay, because again, alternate segment theorem, and then that's equal to 50. And then we could have found this angle here. We could have said 180 minus 50 plus 112, which is 180 minus 162, which is 18 degrees. Same answer. And we could have said that basically, you know, the three angles in a triangle. So we could say angle CBD is equal to 180 minus 50 plus 112 because of angles in a triangle. And we could have found it that way. So there's two ways we could have done this. One way is what we did. We found this angle by the opposite angles in a cyclic quadrilateral. The angle between the tangent and the chord, okay, is, well, then we found what this angle is. This angle FCD by the angles in a straight line, add up to 180, 150 plus 112, and then subtract from 180. And then the alternate segment theorem, this angle here is equal to the angle on the opposite side standing on the same chord. Or as I mentioned, we could have used the alternate segment theorem first to find this angle. This is 50, this is 50. Now we have two of the angles in this triangle. We can find the third. So there's different ways of doing the question. There's probably other ways also, which I haven't maybe considered. Sometimes in these questions, there's more than one way, two-way, three-way sometimes of answering the question. For this particular question, I'm going to put a link to a video where I kind of go through a bit of an explanation of where the alternate segment theorem comes from. If you want to watch that, you can look at the card which explains that, and it will be appearing somewhere over here around now. Okay, and you can click on that link, and also I'll put a link in the description for that as well at the end of the video. So I hope that was clear. Thank you for watching. Other questions from this particular paper will be found in the playlist over here, and also you'll be able to find questions dealing with angles in circles in the new syllabus by clicking on this link over here. You can watch other questions about angles and circles from the old syllabus by clicking on the link over here, and you can subscribe to my channel by clicking on the link on the top. Thank you for watching, and see you soon.